This was all about the processing of the data we have done, and we have created a perfect JSONL which can be trained on a model. Now we will be doing all the setup which is required for the training purpose. Okay, so let's start with the second part of our fine-tuning pipeline, which is training the model on the dataset we have created previously. Now, in this cell, we are splitting the dataset into two. We are using the scikit-learn to import the test train split and splitting the dataset into 80-20 ratio. So 80% of the data records will be used for training and the 20% will be used for validation. Then in the next cell, we are actually loading the model from the Hugging Face in our Google Colab environment, And as you can see, we are using Gemma 2b8. So it's a 2 billion parameter model, and we are loading the tokenizers in the Google Colab itself. So why are tokenizers important? Tokenizers are important because these models cannot understand natural languages. So we will be utilizing tokenizers for replacing the words, or you can say converting the words to the numbers which the models can understand. And as you can see, everything is successfully imported, and the model size itself is 5 GB. So yeah, that's really big as for our computers if we run this on our computer, but in Colab it can be done easily. Then what we are doing is we are configuring low rank adaptation technique, which we were using as I told above. We have set the rank to 32, and this is the crucial part, that we are actually training 0.2. So this means that we are training 2% of the parameters of the 2 billion parameter model. So this technique actually saved us from spending hours and days of training this model to a really short period of time. And it also made this process really efficient, and it didn't cost us anything for creating this small language model. And it's a really great small language model, as I will be showing you in the inference part. Then we are basically configuring the low rank adaptation technique, and then we are actually converting all the examples to the tokens which model can understand. So this is a basic tokenization part. There is a fixed length of 512 tokens. So after this, the examples will be chopped down, and the model won't be trained on those larger examples. All right, and then what we are doing is we have some training arguments here. We can go deep dive into all these training arguments, but I want to keep this video short, and I think this video has got much longer. Although I will explain you a bit. Learning rate is just how fast you want to train the model. The faster you will train the model, the lesser it will learn. So we have to keep in mind about overfitting and underfitting, and we are basically using the very basic average training rate. And the number of epochs is how many times your data set will be revisited. So in our training, we are revisiting this data set only 2 times. And also this was the first iteration. So for the first iteration, I was just testing how great or how good it can do with 2 epochs and smaller batch size and learning rate. And there are other training arguments, you can check it out. After that, we are just initializing the training part, as all the configuration has been done above. So we don't need to worry about anything here. It's just a basic training function we are using. Then the crucial part comes here. We are actually mounting the trained data, the trained tensors and the trained configuration model weights to the Google Drive, so it doesn't get lost. As I have told before, that after 5 or 6 hours the session gets reset, and all the training data, training progress we have made gets lost in the free version of Colab GPU. So I was using this to save the weights in my Google Drive, and then I could easily, like, after mounting to the Google Drive, I can save the model here, and then I can easily load the model in my Google Colab environment whenever I want. So my already trained model is loaded. Like let me show you. So you can see everything is saved here, the config file, the save tensors file. So I don't need to worry about anything. Anything is not getting lost, and I can load it anytime on my Colab environment and use it for the inference. And then we are just loading the adapter here, like from the Google Drive to the Google Colab environment, and then we are doing the complete inference. So we are just using a basic function to clean the JSON response, because sometimes these models are really bad at generating the JSON response. So sometimes they include some junk stuff and all. So I wanted a proper JSON formatted output, so I am using these functions. And the basic proper inference is being done here. We are actually giving a prompt to our fine-tuned model. Why we are giving this prompt to our fine-tuned model? Because our fine-tuned model was trained on very less data, as this was a very first situation when we didn't had a lot of data. So we had to give it a prompt to like optimize its output a bit more. So as you can see, I have given a prompt. It has a role, it has a task, it has a prospect details, and after giving those prompt, we are basically generating the email using that using the above prompt. As you can see here, we have a test utility here which specifies the prospect name, title, company, industry. So these are the essential fields which the user have to give for getting the personalized email generated. And as you can see, there is a personalized email generated which is if you want, you can read, and is really perfect email as the client wanted and was really happy with the output. Although when we were generating this in the Streamlit platform, we were not using the JSON format, we were actually giving the proper copy paste format. But just for the inference and the client needs, I had to do this inference in the console as well. So yeah, that was all from my end, and there are a bit more technical things which we can go deeper into, but as this video has got much longer, I would like to end it here. And I hope you liked the video. We can create different sessions for each type of like process we have done, like explaining all the technical terms and explaining all the technical processes which I had to go through while fine-tuning this model, so everyone can get idea of how to fine-tune a model, but in the later videos. Now this video was only for the explanation of how I built this project, and I hope I have done it well. Thank you very much.